Hello everyone, this is Humphrey again with RouterGods, and in this video it's a continuation of our BGP peering series. So this is part 2, and we're going to take our same topology, our 3-router topology, and we're going to peer from router 0 to router 2. So in the previous video we went from router 0 to router 1 to router 2. Everything's ebgp, so AS 100, 200, and 300. And as I told you in the last video, when you do peering on the internet, usually you're peering with stuff that's probably not connected. So there's a couple routers in between you. Maybe you're peering with Google or YouTube, like our company had to do. So that they're obviously not directly connected, and it's something you'll have to do a lot in real life. So we've got our 3 routers up here. We've got our topology, and we'll start off with router 0. We're going to do conf t, and there's a couple things to remember here. So first of all, actually let's exit out of there. We'll do a show IP route. If we want to peer with router 2, you'll notice that router 2, let's get out of there, scroll back down. Router 2 is at 192.168.60.2. If we look at our show IP route, you'll see that there's no way we can get to 192.168.60.2, and we could just verify that, and nothing's going to come up. But you should have known that just by looking at show IP route, because there's no entry and there's no default route. So, let's put a default route. Let's see if that will work. IP route 0.0.0.0.0.0.0, 192.168.50.2. And that is this address here on router 1. So that's our next hop. Exit out of there, show IP route. Boom, we have our default route, ping 192.168.60.2. Oh, okay, so it's not going to ping. That's probably because the other side's not coming back. We can get there, but from router 2, it can't get back to router 0. So, okay, we'll go back to router 2. Conf t, IP route 0.0.0.0, 0, a lot of zeros. 192.168.60.1, exit. Okay, let's ping the other way. 192.168.50.1. Oh, we can ping. Hit the up arrow on router 0. Great, we can ping. Alright, so that gives us IP reachability. So we think, probably gives away my hand here. Okay, router BGP 100. Pretty easy here. Neighbor 192.168.60.2. Just to make sure, yeah, we're good. Remote AS 300. Okay, and actually let's just leave it at that, and we're going to go to router 2. Minimize that. Conf t, router BGP 300, neighbor 192.168.50.1, remote AS 100, and we'll leave it at that. Go back to router 0. You can see I switch a lot between router 0 and router 2, but that's all right. And let's do show IP BGP summary. Let's take a look. We have 60.2, and we have never and idle. Kind of weird. Let's do a couple things. Well, with ebgp packets, by default they have a time to live of 1. So when it's sending from router 0 to router 2, what's going to happen is the time to live of 1, it's going over here, and when it hits the interface at router 1, that 1 is decremented to 0, and if it's not going to find anything here, it's being dropped. So it's never actually going to reach router 2. So that's one problem. Second problem is that you can't use a default route to get to another neighbor in BGP. So even though you can ping, you have basic IP reachability, BGP is not going to use it for neighbor and peering relationships. It's kind of weird, but I guess You know, they just don't want you to use a default route. It's one of those things. So just to sort of show you that, we're going to take care of the TTL problem. Go router BGP. We're going to do another neighbor statement. Now in BGP you could have lots of neighbor statements. So for the same IP address, it's sometimes you'll have like 10 or so, maybe not 10, but 5 or something like that. And you just keep doing neighbor IP address and then whatever the command is going to be. So we've actually already done that. So to take care of the TTL problem, we're going to do ebgp-multihop on that neighbor. And what that means is to get to the neighbor, we can go through up to 255 hops away, 255 router hops. And this effectively sets the TTL to 255. So that's pretty cool. We're going to set the same thing on the other side. Conf T, router BGP 300, neighbor 192.168.50.1, ebgp multihop. If you don't need 255, if you hit the question mark right there, you can go 1 through 255. You could make it 2, 3, whatever. But usually if you just leave it ebgp multihop, that's fine. Okay. So that gets us to the multi-hop problem, or the TTL problem. Let's do show IP BGP summary again. Oh, okay, so before it was idle, now it's active. Okay, so it's trying to form the neighbor relationship, but it's just not quite working. Let's go ahead and take out our default routes. No IP route 0000 50.2. We're going to take out the default route from the other side. No IP route 0000.192.168.60.1. Okay, so now we have no default route. We're going to put in a specific route. Okay, so what do I mean by that? We're going to say if you want to get to the 60 network, you're going to hit 50.2. So for us, it pretty much is a default route, but it is a little bit more specific. So IP route 192.168.60.0, 255.0.0.0.0, and our next hop on router 0 is 50.2. Oh, okay, yeah, that's a /24. Good troubleshooting there. Okay, we've got that. Let's do the same thing to router 2. Man, my BlackBerry is going off. The joys of working IT. Okay, IP route 192.168.50.0, 255.255.255.0. And the next hop on router 2 is 192.168.60.1. Boom. Okay, let's see if that works. Oh, okay, look, our neighbor relationship has gone up, or so it appears. Show IP BGP summary. Summary, how about that? Okay, we've got, from router 0, we have a neighbor relationship to 60.2, got a couple messages received, nothing's in them, and we've been up for about 11 seconds. So you can see there that after we've done the ebgp multi-hop command and put in a specific route, that the neighbor relationship goes up. So a thing to remember here is you cannot use a default route to get to the other side, to get to your BGP neighbor. It has to be something more specific. So if it's a connected route, hey, that's great. If you're running OSPF or EIGRP, you probably wouldn't between different autonomous systems, but who knows, maybe you are. Then that would work too. So it has to be some way of getting there other than a default route. All right, so in this video, we've covered peering on a non-connected neighbor, so that's great. And in the next video, we're going to cover peering between an internal autonomous system, so IBGP peering. Thanks a lot.